Alright, Module 7, Chapter 2, Transistors. Upon completion of this chapter, you should be able to do the following. Define the term transistor, give the description of the construction operation, explain how the transistor can be used to amplify a signal, name 4 classes of amplifiers to give the explanation for each of the 3 different transistor circuit configurations, explain their operation, identify the different type of the transistors by their symbol and alphanumeric designations. There's precautions to be taken when the transistor describes ways to test them, explain the meaning of the expression and integrated circuits, give the brief description of how integrated circuits construction advantages they offer the conventional transistor circuits. Name the 2 types of circuit boards, state the purpose of functional and modular circuitry. Introduction to transistors. Discovered the first transistor in 1948 with a team of the physician at Bell Telephone Laboratory, sparked with the interest of the solid state. The research was spread rapidly with the transistor became a simple laboratory oddity with a rapidly developing the semiconductor device. A major importance. The transistor demonstrated the first type of the history that amplification in solids was possible. Before transistor amplification was achieved only through electron tubes. Transistor now performed numerous electronic tasks which the new and improved transistor design being continually put on the market. In many cases, the transistors are more desirable than tubes because they are small, rugged, and require no filament power and operate at low voltage comparatively high efficiency. The development of the family transistors have even made possible miniaturization electronic circuit. The figure 2.1 shows the sample of the many different types of transistors you may encounter with working with electronic equipment. An assortment of different types of transistors. Transistors infiltrated virtually everywhere in the scientific industry, from the family of the carrot sunlight. So, even the military depends heavily on the transistor. They are increased. The use of the transistors have created the urgent need for the sound and basic information regarding their operation. From your study of the positive-negative junction diode, the preceding chapter, you will now have basic knowledge of the grasp principle of the transistor. In chapter, you will become acquainted with the basic type of the transistor, the construction and theory of operation. You will also find out just how and why transistors amplify. One of the basic information to understand the transistor terminology, capability, limitations, and identification will be discussed. Last we will talk about transistor maintenance, integrated circuit, and circuit boards, and modularity circuitry. Transistor fundamental. The first solid state device to discover the 2-element semiconductor diode. The next device lists even more unique. Not only with the one more element within the diode, but it can amplify as well. Semiconductor devices have 3 or more elements called transistor. The term transistor derived from the transfer and resistor. The terms adopted because to describe the operation of the transistor, transferring an input signal from a low resistance circuit to the high resistance circuitry. Basically, the transistor solid state device amplifies the control of the flow of the current carried through semiconductor material. There are many different types of transistors, but their basic theory of the operation is all the same. As a matter of fact, their theory they'll be using to explain the operation of the transistor is the same theory used earlier with the positive-negative junction diode, except that now 2 such functions are required to form 3 elements of the transistor. 3 elements of the 2-junction transistor are the emitter, which often emits current carriers, electrons or holes in the base, which control the flow of the current carriers, and 3, the collector will collect the current carriers. Our classification transistor is either known as a negative positive negative or a positive negative positive. According to the arrangement of their negative and positive material, the basic construction chemical treatment is implied by their names. Negative positive positive negative. That is a negative positive transistor form with an introducing region of the positive type of the material between the 2 regions of the negative type of the material. On the other hand, positive negative positive transform is formed introducing a thin region of the negative type of the material between the 2 regions of the positive type of the material. The transistor constructed with a manner where the positive-negative junctions are shown figure 2 and positive-negative junctions between the emitter and base. The other positive-negative junction between the collector and the base. The 2 junctions are the same, share one section of the semiconductor material, with the transistor actually consists of 3 elements. Alright, the emitter, the positive-negative junctions, the collector, and the emitter-base collector, and then on your negative positive, and then emitter, base, and collector on the positive-negative junction. Since the majority and minority currents carry a different negative and positive material, the standard read for the internal operation of the negative, positive, and positive in transistors will also differ. The theory of operation negative, positive, and positive, positive transistor will discuss separately with the next few paragraphs. Additional information from the positive-negative junction will be given the theory of the transistor operates as developed. To prepare forthcoming information, the 2 basic types of the transistors along with their circuit symbol that are shown figure 2-3. They should be noted that the 2 symbols are different. The horizontal line represents the base, the angular line with the arrow represents the emitter, and the other angular line represents the collector. The direction of the arrow of the emitter distinguishes the negative positive from the positive negative of the transistor. The arrow that points in the transistor of the positive negative. On the other hand, the arrow that points out of the transistor negative, positive, negative, not pointing in. So you have points in, positive, negative, positive, and points out and not and point in. Show the emitter, collector, and negative pay, negative pay, emitter, base, and collector, emitter, and base, emitter, collector, positive, negative. Another point you should keep in mind with the arrows always point in the direction of the whole of the flow, or by positive negative section, no matter what the positive is either the emitter or the base. On the other hand, electron flows always toward against the arrow, just like an junction diode. Construction. The binary transistor, well known as the point of the contact transistor. The construction similar with the construction of the point of the contact diode covered in Chapter 1. The difference of the course is the point of contact of the positive and negative region formed instead of one. Each of the two regions constitute an electrode element of the transistor. One aims emitter, the other is named the collector, as shown in Figure 2.4 View A. Point of contact, emitter, base, collector, groove, connection, junction, or rate, ground, connection, positive and negative in the side of the base. Negative or positive on the emitter or collector. Alloy or function, fused conjunction collector, emitter base, diffuse conjunction collector, emitter base. Point of contact transistor, normally practical obsolete. They have been replaced with a junction transistor, which are superior to the point of the contact transistor. Nearly all respect the joint transistor generates less noise and handles more and provides higher current voltage gains. Can be made produced more cheaply within the point of the contact transistor. The joint transfers are manufactured in such a manner as the positive negative joint diodes discussed earlier. However, the positive negative material is grown in view B. Impurity mixing must be reversed twice as to obtain the two junctions required in the transistor. Likewise, an alloy junction view C, the diffuse junction view D process. The two junctions must also be created within the crystal. Although there are many numerous manufactured transistors, one of the most important ways of any of the manufacturing process is the quality control. With a good quality control, many transistors would prove they unreliable because the construction process of the transistor covered in thermal rates and stability electrical characteristics. Even though there are many variations of the transistor manufacturing process, certain structural techniques that yield good reliability, long life, all common to all processes. One, wire leads are connected with each of the semiconductor electrodes to the crystal, is especially mounted to the protective against mechanical damage. And 3, the unit is sealed to prevent harmful contamination of the crystal. Transistor theory. You should recall the earlier discussion forward on that forward bias positive negative junction is comparable to low to resistance circuit element because of the passes high current of the given voltage. In turn, the reverse bias positive negative junction is comparable to high resistance circuit element by using the Ohm's law formula with the power is equal to the amp squared times the ohms. Assuming the current held constant, you conclude with the power developed across the high resistance greater than the developed across the low resistance. Thus, the critical crystal were to contain the positive negative junction on forward base or otherwise reverse biased. Forward bias or otherwise reverse bias, the lower power signal could be injected through the forward bias junction, promote a higher power signal reverse the bias junction. In this manner, the power gain would be obtained across the crystal concepts, which are merely extent of the material covered in Chapter 1, is the basic theory behind how the transistor amplifies with the information fresh in your mind. Let's proceed to the next negative positive, negative transistor, negative positive, negative transistor operation. Just in case the positive negative junction diode of the negative material composed in the 2N section of the negative positive negative transistor contains the number of the 3 electrons, with the center of the positive section contains excessive number of holes. The action of each of the junction because the section is the same that the previously described. The diode, the depletion remains develop regions regions develop and the junction barrier appears. To use the transistor as an amplifier, each of the junctions must be modified by some external bias voltage. The transistor is functioning in this capacity of the first positive negative junction. Emitter base junction is a bias in the forward and low resistance direction. At the same time, the second positive negative junction base collector junction is based on the reverse or high as a resistance direction. A simple way to remember how to properly bias the transistor is to observe the negative positive or the positive negative positive elements to make up the transistor. The layer of the element indicates polarity voltage due to the current bias. For instance, the negative positive transistor below shows forward bias collector negative base emitter. The emitter, which is the level of the negative positive sequence, is connected with the negative side of the battery, which is the base of the second letter MP. Is connected to the positive side of the positive side. However, since the second positive negative junction required with the reverse bias for the proper transistor operation, collector connected with the opposite polarity voltage than the indicator letter designated. Positive designated negative. Voltage of the collector must also be more positive than the base as shown below. Should the forward bias the positive going to the base, and the positive going from the collector reverse bias. We have now properly based the negative positive of the transistor, and then some of the negative positive transistor must be positive with respect to the emitter, and the collector must also be more positive than the base. Negative positive, negative forward base junction. Important point to bring out is the diamonds, which was not necessarily mentioned during the explanation for the diode. In fact, the negative material on one of the side of the forward base junction is more heavily doped than the positive material. This reason is more current being carried across the junction. Majority of the carrier electrons from the negative material through the majority of the carrier hole of the positive material. Therefore, the condition through the forward bias junction is shown figure 2.5. Mainly with the majority carrier electrons from the neutral material emitter. So it shows 2.5 shows the forward base junction and the negative positive negative emitter. When the emitter base junction in the figure base for the forward direction electrons leave with the negative terminal of the battery, enter with the negative material, and since since the electrons are majority with the current that carry with the negative material, they pass in easily through the emitter cross junction combined with the holes on the positive material base. Each of the electron that fills the hole with the positive material, another electron will leave with the positive material, creating a new hole entering the positive terminal of the battery. Alright, negative, positive, negative, reverse base junction. The second positive negative junction based to collective reverse base junction is also called in figure 2.6 block with the majority carry of the currents for the crossing of the junction. However, the very small current mentioned earlier does pass through the junction. The current that is called the minority current of the reverse current. As you recall, the current will produce the electronic hole pairs the minority of the carrier of the reverse base positive negative junction electron of the positive material and the hole of the negative material. Minority carries the actual conducting of the current reverse base junction electrons of the positive material entering the negative material with the hole of the negative material entering the positive material. However, the minority current electrons, as well as you see later, play the most important part of the question, the negative positive negative transistor. Our figure 2.6 shows the reverse bias junction of the negative positive negative resistor. So that goes the positive, negative goes to the base, collector goes to the positive, reverse junction, base junction, reverse current, minority current, and electrons and holes. At this point, you may wonder whether the second with the positive negative junction of the base to collect the forward bias like with the first positive negative junction emitter to the base. If you pull the junction with the forward bias, the electron would have the tendency to flow from each end of the section of the negative positive negative transistor emitter and collector of the center positive section of the base. Essence would have the two junction diodes possessing the common base for the eliminating any amplification, defeating the purpose of the transistor. A word of the caution is in order in the time. If you should mistakenly bias for the second, the positive negative junction forward direction, excessive the current could develop along with enough heat to destroy the junction, making the transistor useless. Therefore, be certain to the bias voltage, polarity, or current before they are any electrical connections. But negative positive negative junction interaction, you need to be ready. That happens when play for the two junction negative positive negative transistor operation at the same time. For the better understanding just how two junctions work together, figure 2.7 during the discussion. Alright, electron flow, reverse bias junction, bias batteries in this figure they're labeled the VC or collector voltage supply with the VB for the base voltage supply. I also note if the base of the supply with the battery is quite small and indicate the number of the shell of the battery, usually 1 volt or less. However, the collector supply with a greater much higher than the base than the supply normally around 6 volt. As you will see in the difference of the supply voltage necessary to have the current flow with the emitter with the collector. As stated earlier, the current flow with the external circuit is always due to the movement of 3 electrons. Therefore, the electron flow with the negative terminal of the supply battery to the negative type of the emitter that combined with the movement of the electrons known as the emitter current, or i.e. electrons the majority with the current with the and the negative material. This one with the negative material and emitter the emitter base junction with the junction forward base of the electron continue the base region. And once for the electrons are in the base, which for the positive type of the material, they become minority carriers. Some of the carriers, some of the electrons that move within the base recombine with the available holes for each of the electron around and recombines another electron move through the base lead with the base current or IB, creating a new hole with the eventually combination return to the base supply of the battery. VBB. Electrons can recombine the loss of the far of the collateral concern, but therefore to make the transistor more efficient, the base region may be very high, thin or lightly doped. The reduce the opportunity of the electron to recombine with the hole to be low if the most electrons moved into the base region under the influence of large collector reverse bias. This bias acts as the forward bias for the minority of the electron into the base, as such that the electron through the base collector junctions are into the collector region. Since the collectors are made with the negative type of the material, electrons reach for the collector again with the majority carriers. Once for the collector, electrons move easily in through the negative material, return to the positive material terminal with the collector supply battery VCC as a collector current IC. To further improve the efficiency of the transistor, the collector is made physically large for the base for the two regions, for the increase for the change, for the collecting with the carriers, for the diffuse for the side, but as well directly across the base region to enable the collector to handle more heat without damage. In summary, the total current with the negative positive negative transistor is through the emitter lead with the route. Therefore, in terms of the percentage as the amperage is 100%. On the other hand, the base is very thin and lightly doped with a smaller percent of the total current. With the emitter current will flow with the base circuit with the collector circuit. Usually no more than 2 to 5% of the total current base or IB, while remaining the 95-98% of the current collector current. Very basic relationship that exists between the two currents. The amperes amperes volt is equal to the amperes base times the amperes collector current. All right, in simple terms, the amperes emitter is equal to amperes base plus amperes current, collector current. In sample terms, the meaning of the emitter with the current separated with the base and collector current, since the amount of the current leaving the emitter with the solely function of the emitter with the bias base bias, because of the collector receives most of the current of the small chamber. The emitter with the base bias will have the far greater effective of the magnitude of the collector current that will have on the base current. In conclusion, relatively small emitter base bias control with the relatively large emitter with the collector over the current. Positive, negative, positive, the transistor operation. The positive, negative, positive, the transistor works essentially the same with the negative, positive, and negative transistor. However, since the emitter and the base of the collector of positive, negative, positive transistor are made with the material of a different type of those used in the negative, positive, negative transistor, different currents carries flow over the positive, the negative, positive unit. The majority current carrier of the negative, positive, current carriers in the positive, negative, positive transistor are whole with the contrast of the negative, positive transistor, which are majority current carriers in electrons to the support with a different type of the current, but the whole flow. The bias batteries are reversed for the positive, negative, positive transistors, and the typical base setup of the positive, negative, positive transistor shown in Figure 2.8. Note for the procedure that usually early properly with the bias for the negative transistor also applies here to the positive, positive transistor. The first letter P is for in the sequence indicates the polarity of the voltage required for the emitter positive, and the second letter N indicates the polarity of the base voltage negative. And so the base collector junction is always reverse base for the opposite polarity voltage negative. It must be used for the collector. Thus, the base for the positive, negative, positive the transistor must be negative with the respective emitter of the collector must be negative, and then the base. Remember, just in case of the negative positive transistor, the difference of supply voltage necessary to have the current flow into the positive, negative, positive transistor from the emitter of the collector. Although the whole flow with the predominant type of the current flow with the positive, negative, positive transistor, the whole flow only takes place when in the transistor itself, with the electron to the external circuit. However, the internal whole flow that leads the electron flow with the external wires connected to the transistor. 2A shows the property base positive, negative, positive transistor. Notice that the negative is actually on the collector, and the forward and the negative on the bias on the base. Positive, negative, positive, negative, positive, forward base junction. Now let us consider the half of the emitter base for the junction figure 2.9 with the forward bias of the bias set up the shown with the positive terminal on the battery with the repel with the emitter hole with the order of the base of the the negative terminal drive the base for the electron toward the emitter. When the emitter hole with the base electron meet with the combine with each of the electron combined with the hole with another electron leave the negative terminal over the battery, enter the base. At the same time, the electron leave the emitter, creating a new hole, enter the positive terminal over the battery, and this moving the electron into the base of the outer emitter constitutes a base current flow or IB. The path of these electrons referred to the emitter base circuit. Figure 2.9 shows the forward bias junction and positive, negative, positive transistors. Electron flow, hole flow, from the negative to the base, flowing from the emitter to the voltage, or like this. Or your positive, negative, positive, the reverse bias junction, the reverse bias junction, and the negative for the voltage for the collector, for the positive, for the voltage for the base, black with the majority current, carry over the crossing of the junction, however the same of the negative collector voltage, across the forward bias for the minority current, hold for the base for the cross junction, enter for the collector for the minority current, electron for the collector, sends forward bias, positive base voltage moving into the base, the holes of the collector of the fill with electrons that flow over the negative terminal of the battery. At the same time, the electrons leave the negative terminal over the battery. Other than electrons base break the covalent bonds that enter the positive terminal of the battery. Although the only minority current flow versus bias junction is still very small because of the limited number of the minority current carriers. Once again, positive has the arrows going in. This one reverse current, minority current, is running from the electron from the base into the collector from and reverse bias junction. Okay, the positive, negative, positive junction interaction. The interaction between the forward and reverse positive, negative, positive transistor varies. Some of the negative, negative transistor, except for the positive, transistor. Majority of the current carries all the whole of the positive, negative, transistor shown in figure 2 above. Go 11, the positive voltage on the emitter repel the holes toward the base. Once the base hole is combined with the base electrons, but again with the base region, they may very thin with the prevent recombination from the holes within the electron. Therefore, well over 90% of the holes entering the base become attracted to the large negative control voltage, collector voltage pass right through the base. However, the electron in the holes combined with the base region and enter another electron leave the negative terminal of the base base battery. Terminal of the base battery, enter for the base of the base current. At the same time, the electron leave the negative terminal of the battery, and another electron leave the emitter, creating a new hole. Enter the positive terminal, VB, or base, the positive terminal of the base volt, the base battery. Meanwhile, with the collector, second of the electron with the current collector battery voltage, enter the collector with the amperage current. Amperage of the collector, combining with an excessive hole of the base there, each with the neutral with the collector for the electron, and another electron leave the emitter, and start its way back in the positive terminal of the collection battery, voltage collection battery. Alright, positive, negative, positive transistor operation, forward base junction, reverse base junction. Although the current flow over the external circuit of the positive, negative, positive transistor the opposite direction of that of the negative, positive transistor for the major carrier that allows flow over the emitter of the collector through the flow of the majority of the carrier that all the result of the information to the individual current loop within each of the transistor, one loop for the base current for the path, the one loop for the current collector current path, for the combination for the current both of these levels areas that amps of the base plus amps of the collector, result of the total transistor of the amp of the transistor. Most important thing to remember the two different types of the transistor of the emitter base voltage, positive, negative, positive transistor, and the same with the controlling effect with the collector current with the negative, positive transistor. In simple terms, increasing the forward base voltage of the transistor reduces the emitter base junction barrier. The action will allow the more carriers to reach the collector, causing an increase of the current flow with the emitter of the collector through the external circuit. Conversely, decrease the forward bias voltage to reduce the collector current. Alright, the basic transistor amplifier. Then proceed with the pages we explain with the internal work with the transistor, introduce the new terms for the emitter, base, the collector. Since you should be familiar with it now with all the new terms we mentioned earlier with the internal operation of the transistor, we'll move on to the basic transistor amplifier. To understand overall operation of the transistor amplifier, you only need to consider the current with an in and out of the transistor, therefore the various components of the circuit. Therefore, the points on only the schematic symbol of the transistor will be the illustration. Rather than thinking about majority and minority carriers, we'll now start thinking in the terms of emitter, base, and collector current. Before going into the basic transistor amplifier, the two terms should be familiar with the amplification, amplifier. Amplification is the process increasing the strength of the signal. A signal is a general term they usually refer to a particular current voltage or particular port power and source. Any amplifier device provides the amplification to increase the current voltage and power of the signal without appreciable alerting of the original signal. Transistors are frequently used as an amplifier, such as transistors, circuits, or current amplifiers with the same load resistant. Other circuits designed in voltage amplification have the load resistance over the others amplify power. Now take into look the negative positive negative version of the basic transistor amplifier figure 212. Let's see how it works. So far in this discussion, the separate battery has been used to provide the necessary for the forward bias voltage. Although the separate battery has been used for the path of convenience for the not particular for the battery for the emitter base bias. For instance, it would take a battery slightly 0.2 of a volt to properly forward bias a germanium transistor, while the similar silicon transistor would require voltage slightly over 0.6 of a volt. However, the common batteries do not have such voltage values. And also, since the base of the voltage are quite critical, that must be held with a few tenths of the 1 volt, easier to work with the bias circuit currents flowing through the resistors of a high ohmic value than with batteries. By inserting one or more resistors in the circuit, the different methods of basic biasing may be achieved. The emitter-based battery eliminated additional limiting of the battery. Some of the biasing method of compensating slight variations of transistor techniques, changing the transistor conditions resulting from the temperature irregularities. Notice for the figure 212, the emitter-based battery has eliminated the bias resistor of the RB. Have been inserted with the collector in the base of the resistor provided the necessary for the forward bias of the emitter of the base junction. Current flow with the emitter base circuit from the ground to the emitter of the base lead through the base voltage and the base current. Since the current in the base of the circuit is very small, with a bit 100 of the microamp, the forward air resistance of the transistor low with only a few tenths of the volt, with the positive base bias will be felt on the base of the transistor out with enough of the voltage on the base along with the ground emitter with large positive voltage of the collector properly based the transistor. Alright, with Q1 being based bias directly current flow with a continuously without an input signal throughout the entire circuit with a direct current through the circuit developed more than just the base bias. It also developed the collector voltage. As flow with the Q1 and the resistor load, notice the collector voltage of the output with the graph into the present of the circuit is without the input signal and output signal start of the collector voltage and level, and either increase the degree of the DC voltage current exists for the circuit before the application of the signal known as the quiescent voltage is occurring in the quiescent state of circuit. The resistor or the collector load resistor is played with the circuit to keep the full effect of the collector of the supply voltage off the collector, the permit of the collector voltage to chain with the input signal within its turn allows transistor to amplify the voltage without the collector load resistor, and the circuit of the voltage on the collectors would always be equal to the collector voltage. Current. The coupling capacitor is known as another new addition to the transistor circuit to be an AC signal input with the block of the DC voltage from preceding circuit with the preventing the DC and circuit to be left on. The coupling capacitor affecting the bias for the Q1. The coupling capacitor also blocked with the basis for the Q1 from reaching the input signal source. Input of the amplifier soon wave the vary for a few millivolts above and below zero. It is introduced into the circuit of coupling when the capacitor applied between the base and the emitter. After the input signal goes to the positive voltage, go for the emitter base junction, but more positively and effectively increase the forward bias, which cover the current base current with the increase at the same rate with the input sine wave. Emitter collector currents also increase much more than the base current with the increase of the collector current with the more voltage dropped across the collector load resistor. Since the voltage of the collector load resistor, the voltage across of the collector emitter or Q1 must add up to the voltage collector to increase the voltage of the collector load resistor, result in the equal decrease of the voltage across the collector to emitter. Therefore, output voltage of the amplifier taken within the collector of the output, the collector emitter within the respect of the emitter, the negative alteration voltage larger than input, but the same sine wave is characteristics. During the negative alteration of the input signal output with the forward bias with the action decrease the base current with the result of the decrease of both emitter and collector currents decreases the current of the collector load resistor with the decrease of the voltage drop the cuff of the voltage across the transistor rise along the output voltage. Therefore, the output of the negative alteration of the input with the positive alteration voltage is larger than the input of the same sine wave characteristics. By examining input and output signal with one complete alteration of the input, we can see that the output amplifier is exact reproduction of the input except for the reverse polarity and the increased amplitude, few millivolts compared to the few volts. Positive version of the amplifier shown in the upper part of the figure. The primary difference between the negative and positive amplifier, the polarity with the source of the voltage with the negative of the voltage collector with the positive current of the positive and negative positive base voltage slightly negative with respect to the ground provided the necessary forward the bias condition between the emitter and the base. When the positive input of the signal goes positive, the opposite with the forward bias of the transistor, the actions cancel with the negative voltage across the emitter base junction to reduce the current through the transistor. Therefore, the voltage across the load resistor decrease the voltage across the transistor, increase the voltage collector current as negative as the voltage of the collector. Go over the negative direction shown with the output of the graph of the negative voltage collector current. For example, the negative 5 volts, negative 7 volts for the output with the negative alteration voltage varies. Same with the rate is the same way the input of the output of the polarity have a much larger amplitude. During the negative alteration, the input signal with the transistor current increases because of the input of the voltage A with the forward bias. Therefore, the voltage across the load resistor current load resistor collector increases consequently. The voltage across the transistor curve that goes in the positive direction, for example, the negative 5 volts and the negative 3 volts, this action will result in the positive output voltage, which has the same characteristic input, except that it has been amplified. Polarity is reversed. In summary, the input signal of the preceding circuit is amplified because of the small change of the bias current, called the large change of the collector current. Also called the placing resistor in series of the collector of the voltage amplification was achieved. Or your type of bias. Once the basic problem of the transistor amplifier is established, we're going to maintain proper values, quiescent current with the voltage in the circuit. They accomplish with the selecting the proper circuit bias condition, ensuring that these conditions maintained despite of the variation in the ambient surroundings, temperature which will cover the amplification, even the distortion, unwanted change of the signal. But these need to arrive at the method to properly bias the transistor amplifier, same time with the stabilize with the DC operating point. There's no signal value for the current voltage, collector voltage for the collector current, collector voltage or collector current that is maintained. As mentioned earlier, the various basing methods can be used to accomplish both of these functions. Although there are numerous methods, basic biasing methods, only 3 basic types will be considered. Or your base current bias fixed base. If the first biasing method of the base current bias is called the fixed bias, which is usually figure 212, we call the consequently basic resistor connected between the collector supply with the voltage of the base. Unfortunately, simple arrangement, quite thoroughly unstable in temperature. If the temperature rises the transistor region for any reason due to the rise of ambient temperature for the current flow through it, the collector current will increase. The increasing current will also call the DC output operating point, sometimes called the quiescent or static point, to move it away from the desired position level. The reaction with the temperature is undesirable because of the effect of the amplifier gain. The number of the terms amplification could result in a distortion, as well as you see in the discussion. Self-bias. A better method of the biasing is obtained by inserting the bias resistor directly between the base and the collector. The shown figure 213 by tying the collector to the bias. In this manner, the feed voltage can be fed back for the collector base to develop the forward bias of the arrangement is called the self-bias. Known as the increase the temperature cover, the increase the collecting current and the collector voltage. The fall will be covered the increase the voltage produced across the load resistor. The drop of the collector voltage will feed back to the base with the result of the decrease of the base current. The decrease the base current will oppose the original and increase the collector current that is tended to stabilize it. The exact opposite produces the collector current decreases. So what they added was a resistor to the self-bias to the transistor. That's called self-biasing. Self-biasing has 2 small drawbacks. Only properly effective, therefore it is only used with a moderate change of the ambient temperature. Expect to reduce the amplification signal over the collector, but also affect the base voltage of this because of the collector and the base signal. In particular, amplification configuration 180 degrees out of phase. Opposite with the polarity of the collector signal is fed back with the base for the same cancel with the same input signal process report. The process of the returning part of the output with the back end of the input signal is known as degeneration, negative feedback. Sometimes the degeneration desire prevent amplitude distortion output, but the signal with the flow of the input is exactly self-biasing may be used for this purpose. Or your combination bias. The combination of fixed and self-bias can be used can be used to improve the stability, at the same time overcome some of the disadvantages of the other type of the 2 biasing methods. One most widely with the combination of the bias system with the voltage divider type. Shown figure 214, the fixed basis provided the circuit of the voltage divider network consisting of resistor 1, resistor 2, collector high voltage, and the DC current flowing through the voltage divider network base. The voltage base positive respect to the emitter resistor R3, which is the connector with the resistor, the series of the emitter will provide the emitter with the self-biasing sense of the amperes Amperage voltage, increase the voltage drop of the curve of the resistor 3 will increase the collector voltage supply voltage for the reaction with the increase of the amperage amperage volts by amperage total by resistor 3 and other form of degeneration result in less of the output with the amplifier. However, the provide long-term with the thermal stability at the same time allow the minimum AC signal degeneration by bypass capacitor is placed in the resistor 3 of the bypass capacitor is large enough to rapidly signal variation will not though change to charge partially or no degeneration of the signal will occur. Figure 214 show the basic transistor amplifier with a combination bias. You notice you have the resistor and the capacitor fixed bias. In terms of the fixed bias resistor 1 and resistor 2 tend to keep the bias constant, while the emitter bias change with the emitter with the condition the action greatly improve with the durability of the stability at the same time that maintain with the correct operation of the transistor. Amplifier class of the operation. Previous discussion, we assumed that every portion of the input of the signal there was an output from the amplifier. That's not always given to the amplifiers. You must desire with the transistor connecting only with the portion of the input signal to the portion of the input where the output, in terms of the class operation of the amplifier, floor class of the amplifier amplifying operations, they are Class 1, Class A, B, Class B, and Class C. Class A amplifier operations. Class A amplifiers are based on the variation input signal polarities occur within the limit of the cutoff of the saturation, the positive and negative power of the transistor. For example, if the base becomes live with respect to the emitter hole with the repel with the positive and negative junction, no current can flow over the collector circuit. If the condition is known that the cutoff of the saturation curve of the base becomes so negative with respect to the emitter chain that the signal will not rectify and reflective of the current flow, collector current flow. Biasing the amplifier with the mannered places of the DC operating points being cut off with the saturation allows the current collector to flow during the complete cycle of the 360 degrees input signal to provide the output of the replica of the input of the figure 212. The example of the class 1 amplifier through the output of the amplifier is 180 degrees out of phase. The input of the output current still flow through the complete duration of the input of the class A operated amplifiers using the audio radio frequencies amplifier radio radar sound system just as mentioned. For example, if you were to mention, for example, the comparison output signal different amplifier classes of the operation for the figure 215 during the following discussion. Alright, Class A, B, Class B, Class C. Area of no condition is the shaded. Comparison of the output signal for the different amplifier class operations. Class AB amplifiers operation. Amplifiers designed with the Class AB operation are based on the collector current with the zero cutoff for the portion of the one alternation input signal with the accomplished with the makeup of the forward bias voltage less than the peak of the value of the input voltage. Input signal doing this is a basic emitter junction with the reverse bias during the one alteration amount of the time that the input signal voltage opposes exceed the flow value of the forward bias voltage. Therefore, the collector current will flow for the floor more than 180 degrees, but less than 360 degrees. Input signal is shown with figure 215 view B as compared with the classifier A. The DC operating point of the class A and B is closer to the cutoff. The class AB operated amplifiers commonly use the push-pull amplifier to overcome the side effect of the class B operation called crossover distortion. Class B amplifier operation. Class B amplifiers based on the bias show that the current is cut off during one half of the input signal of the classifier of the Class B with the DC operating point of the classifier amplifier set off the base for the current zero. That no input signal is amplified with the 1/2 second of the forward bias of the base emitted with the junction over the amperage collector. Will flow. The other half cycle with the reverse bias of the base emitted over the amperage current amperage collector will be cut off. Thus, the Class B operation, the collector will current will flow with approximately 180 degrees. Half the input signal shown figure 215 view C. The Class B operated with the amplifier extensively auto amplifiers to require the high power outputs of the U for the driver and power amplifier stage transmitters. Class C amplifier operation. Class C operation current flow for the less than 1/2 of the cycle of the input signal shown figure 215 view D. But the Class C operation is achieved by the reversing by the emitter base junction, which sets the DC operation below the cutoff of the allow the only the portion input signal that will come to the reverse by the collector current flow of the Class C operated amplifiers using the radio frequency amplifier transmitters. For the brief description, you conclude with the two primary items determine the class of the operation of the amplifier, the amount of the bias, the amplitude of the input signal. With a given input signal with a bias level, you can change any of the amplifier from Class A to Class B just by removing the forward bias. So a Class A amplifier can be changed to Class AB by increasing the input of the signal input amplitude. However, the input and signal amplitude increase the point of the transistor go to the into saturation cutoff, and this is known as called the overdriven amplifier. You should have familiar with the term of the junction of the amplifier fidelity and the inefficiency. Fidelity of the faithful reproduction of the signal, and otherwise the output of the amplifier amplifier adjustment input with the amplitude of the amplifier with a high degree of fidelity, the opposite with the fidelity with the we mentioned earlier with the distortion. Therefore, the circuit with the high fidelity with low distortion. Conclusion A, the amplifier high degree to fidelity with the class AB amplifier, less fidelity with class B, and class C amplifiers have low port fidelity. Alright, efficiency power refers to the ratio output signal compared with the total input power of the amplifier with the two inputs, for the one for the signal, one for the power supply. Since every device that takes the operator power to operate the amplifier operates 360 degrees input signal, usually power to operate with 108 degrees input signal. Use more power for the amplifier with the less for the available to output signal. The efficiency of the amplifier is low. This is in the case of the input with the classifier amplifier operates 360 degrees input signal requires the relatively low and large input of the power supply, even though no input signal with the class A amplifier still power the power of the supply. Therefore, the output of the class A amplifier relatively small compared to the total input power. The result of the low efficiency of the acceptable the class A amplifiers become the useful efficiency of the important fidelity. Class A, B are based on the collector current with the cutoff of the portion of the one alteration input with the result of the total input power with the Class A amplifier with the least for the better efficiency. Class B amplifiers are based on little or no collector current during the DC operation point, whether no input signal, there's little wasted power, therefore efficiency of the Class B amplifier is higher. Still, the efficiency of the Class C is the highest of the four levels of the amplifier operation. Transistor configuration. Transistors must be connected one or three basic configuration. Common emitter with the common base, the common collector with the term, with the common edge of the node, with the element with the common both of the input and output. Because the center of the common element is often grounded. These configurations are frequently referred to as ground emitter, ground base, or ground collector. Shows the common emitter, common base, and common collector. Each configuration will you will see later the particular character that's most suitable to the specific application. You identify the specific transistor and transistor configuration as follow these three simple steps. Identify the emitter, emitter base or collector with the input signal applied. Identify the element with the emitter base collector with the output signal taken. The remaining element with the column element give the configuration its name. Thereby applying the three-step step for the circuit of figure 212, we can conclude that this circuit must be the basic transistor amplifier with the common emitter amplifier. Common emitter with the configuration shown in the figure 216 view A of the arrangement must frequently use the power for practical amplification circuits. They should be with a good voltage with current and power gain with the common emitter is somewhat lost for the input resistance of 500 ohms and 1500 ohms to cover the input supplied with a force-based junction with moderately high output resistance 300 kilo 30 kilo ohms or 50 kilo ohms. The more they cover the output, they take in the reverse bias junction terms. The input signal is applied. Base emitter circle with the output is taken from the collector emitter circle with the emitters and the element, the common both the input and output. Since you have already covered what you know to be the common emitter of the amplifier, figure 212, let's take a few minutes to review the operation of the positive negative power of the common emitter with the configuration shown in figure 216 view A. The transistor connected with the common emitter with the configuration input signal injected between the base and the emitter with low resistance and low current. Circle with the input signal swings positively cover the base with the swing positive with respect to the emitter. The action to create the forward positive to reduce the collection current, increase the current voltage for the making the voltage collector more negative with the negative alteration with the input signal the base driven more negative than the respect for the emitter. The increased forward bias allow for the more current carriers to release from the emitter with the result of the input with the collector current and the decrease of the collector voltage less negative than the swing of the positive direction. The collector current that flow through the high resistance reverse base junction are also flow with the high resistance load not shown, resulting in high level of amplification. Since the input signal with the common emitter goes positive, the output but goes negative. The two signals input and output are 180 degrees out of phase. The common emitter circle is also only the configuration that provides the phasal reversal. The common emitter is the most popular of the three transistor configuration because it is the best combination of the current and voltage gain. The gain is used to describe the amplification capability of the amplifier, basically the ratio of the output versus the input of the existing transistor configuration with a different volt value of the gain even with the same the transistor use. Transistor configuration used in the matter of the designing the consideration. However, the technician will probably be interested in the output versus the input of the gain to determine whether or not the transistor working properly in the circuit. The current gain with the common emitter is called beta. Beta is the relationship of the current collector current output current to the base of the current input current. To collect the beta, use the following. Beta is equal to the I believe that would be the collector current output over the collector current base current. For example, the input current is the common emitter chain with a 75 to 120 microfarads, and the output current is changed from 1.5 milliamps to 2.64 milliamps will be gained 4 to 4. Simplest way of the change of the base current provided with the change of the collective current within 44 times the larger. As you must be have the term HFEE used in play for the B. The terms A, F, E, and B are equivalent and may be even interchangeable because the H, F means hybrid mean mixture of the forward current transfer ratio and a common emitter configuration. The resistance gain with the common emitter with the found with the methods similar to used one on the following beta. Once the resistance gain, the voltage of the calculate the equal to the current the gain voltage multiplied resistant gain. And power gain equal to the voltage gain multiplied with the current of the gain. Your common base. The common base configuration shown in Figure 216 with the view B with only the impedance the matching with the hello input with resistance 330 to 160 ohms, output resistance 250 kiloohms to 500 kiloohms. However, the two factors limited useful of some of the circuit applications is the low input resistance for the current gain with less than 1 and the common base configuration give the voltage of the application. There are some additional applications required with both the low input resistance for the voltage of the application and the circuit configuration for the type of, for example, of some of the microphone amplifiers. Common base configuration input signal implied with the emitter of the output to take with the collective of the base of these elements with the common both the input and output. The input is supplied with the emitter of the emitter base junction to react with the same emitter often deal with the common emitter of the circuit. This, for example, the input of the A for the biafter will increase the transistor current. The one up over the biafter decrease with the transistor current. Like this common emitter, the common emitter circuit input and output equal to the common base circuit are in the behavior. The two illustration point with the input with the positive version with the common base circuit in Figure 216 view B with the power with the signal and with the forward bias with the sim supply with the emitter with the collector current to increase the increase of the amperes collector and the amperes collector the greater voltage with the drop of the current of the load resistor not shown lowering the drop in collector voltage. Collector voltage become less negative as swinging with the positive direction, therefore the favor the incoming positive signal. The current gaining the common base circuit is calculated with the method also of the common emitter except for the input signal I is not IB. The term alpha is used in place of beta for gaining alpha. The relation for the current collector output current and the emitter of the input current. Alpha is calculated by using alpha is equal to the amperes for the collector over the amperes of the emitter. For example, the input of the current with the common base chain with the 1 milli 3 milli. The output current changes from 1 milliamp to 2.8, and the current gain is 0.9. Alright, since the parts of the emitter can flow through the base if it does not appear with the collector current will always be less than the emitter current that causes it, and the current that causes it. Remember that the voltage is equal to the voltage and the amp the emitter is equal to the amperage of the emitter is equal to the amperage of the base times the amperage of the base plus the amperage of the collector. Therefore, the alpha always less than 1 for the common base configuration. Although the term alpha is determined as terms are HF, they're equivalent to maybe interchangeable. In the name of the term HF is derived in the same manner with the HEFE mentioned earlier, except that the letter E has been replaced with the B to stand for the common base configuration. Too many transistor manuals data sheet with only the transistor current gain with the character of the beta to find the alpha to give it the beta, and with the given beta of the U found in the formula with the correct beta to alpha the U of the common base configuration. Alpha is equal to beta time plus beta over the beta time plus 1. To calculate other gains of the voltage power with the common base configuration when the current with the gain of the alpha is known with the procedure described earlier within common emitter section. Or your common collector. The common collector configuration shown in Figure 216 view C with the mostly used impedance match alpha is also U with the current driver with the substantial of the current gain that is the practical U with the switch array circuit that has the ability to pass signal with either direction by lateral operation. The common electric circuit Common collector circuit with its input signal applied with the base of the output to take from the emitter for the collector of the element of the common of both the input and output, and the common collector is equivalent to our older friend electron tube cathode follower. Both have the high input with the low output. Resistant input, resistant collecting collector ranges from 2 kiloohms to 500 kiloohms, and the output resistance varies from 50 ohms to 1500 ohms. The current gain higher than the common emitter with both button, lower gaining with either the common base of the common emitter, life of the common base of the output signal with the common collector. In favor, the input signal of the common collector is also referred to as emitter follower, and the common collector is also referred to as emitter follower because of the output development of the emitter follower with the input signal applied to the base. The transition action of the common collector is similar to the operation explained with the common base, except for the current gain is not based on the emitter collector to the current ratio alpha. Instead, is based on the emitter base current ratio called gamma, or Y, represented with the Greek symbol Y. Because the output is taken out of the emitter, since the change of the base control large change of the emitter, it is possible to obtain the high current gain in common collector. However, since the emitter current gain is offset by the low output resistance, the voltage gain is less than 1 unity, except for exactly to the electron tube cathode follower. The common collector current gain, or gamma, is defined as gamma is equal to the amps of the emitter over the amps of the base. Related to the collector base for the current gain of the bed of the common emitter circuit be as the your gamma is equal to beta to plus 1. So given the transistor being connected with the three basic configuration, the defined relationship pointed out earlier, the alpha and beta and the gamma, these relationships are listed again with the conveniency. Alpha is equal to beta over beta plus 1, or beta is equal to alpha over 1 minus alpha, or gamma is equal to beta plus 1. For example, the transistor listed with the manufacturer's data sheet with having the alpha of 0.9 will use the common emitter of the configuration. This will mean the find the beta of the calculations, or beta is equal to alpha over 1 minus A, or 0.9 minus 1.9 will give you 9. Therefore, the change of the base of the current transistor produced the change in the collector current will be 9 times as large. If you wish this same the transistor common current, you will find the gamma by gamma is equal to beta plus 1 equal to 9, or 9 plus 1 equals 10. Summarize the property of these transistor configuration comparison chart is provided in table 2.1 for summary. Input amplifier type of the common base of the common emitter, common collector. Common base 0 degrees, common emitter 180 degrees, common collector 0 degrees, and that was an input-output phase relationship. Voltage gain high for common base, medium for emitter, low for common collector. Current gain low for common base, medium for emitter, high for collector. And power gain low for common base, high for common emitter, medium for common collector. Input resistance low for common base, common emitter, medium, common collector, high. Output resistance high, common base, common emitter, medium, and low. Now you have analyzed the basic transistor amplifier, determined the value for the class of operation circuit configuration. Let's apply what they have covered in Figure 212, the reproduction. Figure 212 is shown below with the conveniency. The illustration is not just because the basic transistor amplifier should be earlier than Figure 212, but as the Class A amplifier configured with the common emitter, they use the fixed base. From this, you should be able to conclude the following: because of the fixed base of the amplifier thermally unstable, because of the Class A operation, the amplifier has low efficiency but good fidelity. Because of the configuration, common emitter amplifier has good voltage with current and power with the gain. In conclusion, the type of the bias and class operation circuit configuration all clues for the function possible application of the amplifier. And I think we're going to cut the tape there. We're about halfway through there. Transistor specifications.